Thakur Vidya Mandir High School and Junior College welcomes all the 12th standard computer science students. We are going to learn the last connectivity device and we are going to learn a new concept Ethernet in network architecture from the lesson networking technology. Already connectivity device we have discussed in detail about routers, hub and repeaters in detail. So we will learn today a new concept of the connectivity device. Now, what is a router? Router is nothing, it is a device which is used to connect two similar or dissimilar LANs. Why I am saying here two dissimilar or dissimilar LAN? Because here there are many LANs and each and every LAN will be following a different rule. We call it as a protocol. So, it is a device which is going to connect two or more different LANs. Simple thing, it will be connecting all the LANs together to form a WAN network. So here they are used to connect two topologies similar or dissimilar LAN. Each LAN is logically separate and it is assigned an address. Now, router from the name itself signifies router is a device which is going to route the data. They are very intelligent. They deliver the packet properly from one destination to another destination without any distortion. Whenever it is sending the data, they use algorithms in order to transfer the data from one computer to the another computer. Now, whenever we are going to ahead with the algorithms become a part of the software device. And router is nothing, it is a black box that we will see in the diagram or a device which is used for routing the data. So simple thing I will say, router is a combination of both hardware and software. Whenever the data has to be transmitted, the device is called as the hardware. The physical layer device, we call it as the hardware part. And since it is following algorithms to transfer the data, that is the rules. And that, what do we call it as? The software part. And whenever the data has to be transmitted, they will be broken down into small packets called as frames. Each and every frame will be having a source and a destination address so that it properly reaches the destination. Now let us understand the diagram of routers. So you can see here there is my network A which is having two computers which is connected to a router. This is my router 1. So this is my router. This is my first network with two computers. See how this router of network A is connected to the router of network B, which is having just one computer. Now this is network C with two computers. Again we have a router here which is going to interconnect network B and C together. And lastly, we have one more router here, which is for network D. So again, network D is having two computers. So you can see here how the routers are interconnected. So in this way, routers are interconnected. So you can see from the above diagram that a router is a device which is going to connect more or two or more networks together so that they transfer the data from one network to another network. So here the network A, B, C, D, they might be having the same routes, that is the protocols, or else they might be following a different routes. Their topology might be different, but we are going to interconnect them together by a device called as router. So this is how a diagram shows in which all the four networks are interconnected with the help of my router. So router is going to route the data from one network to the other network. Let's learn about router. Router are inter-network connectivity device. You can see there are many computers together connected to expand the network. It is used to interconnect two or more independent networks. It can be a LAN or a WAN. Mostly it will be LAN so that we can interconnect many LANs together to form a LAN. And they are independent. They don't depend on each other. They are used to connect two topologies similar or dissimilar LANs. Topologies that is used for the construction of the LAN can be similar or it can be dissimilar. Router is a combination of hardware and software. As we discussed, router is a combo of hardware and software. So what is the hardware? The physical device. And what is the software? The algorithms they follow in order to transfer the data. So the hardware can be a network server, a separate computer or a special black box device which is used for routing the data. A software like algorithms are used to determine the best path by which to send a signal packet. So whenever we are going to transfer the signal in packets, which is called as frames, and the routing is being done with the help of the software. So hardware is the device which is used for routing, and how it is going to route the data, that is followed by the software. Routers. Each LAN is logically separate and is assigned an address. As we discussed, there are LANs. There are many LANs when I am going to interconnect. Each and every LAN will be having a separate assigned address. Routers can use network devices to assist efficient delivery of message. So they use this address of LAN in order to deliver the data in a smooth way. Delivering packets according to the logical network address is called as routing. That is, whenever the packet of data is being delivered from one network to another network, the process is called as routing. As we said that the router is nothing, it is going to do a routing process. Routers perform routing. Routers are intelligent. They can use algorithms to determine most efficient path for sending a packet to a given network. So they use this algorithms, which is nothing the software, in order to determine the path and for sending the data to any network in a smooth way. Routers can be used to divide a large busy LANs into smaller segments. So whenever there is many LAN, a big LAN of 1,000 computers, we are going to divide it into smaller and route it and use a router in order to transfer the data from one LAN network to the another LAN network. Routers. Routers are also employed to connect LAN to wide area network, as we have discussed. A router maintains a table of available routers and the status. So a table is maintained in a network to count the number of routers and what are the address of the router, so that with the table we will come to know which router is in working, which router is at rest, and how the data has been routed, that is the status. The router uses this information along with the routing algorithm to determine the best route. So as I said, they are very intelligent, they are very smart, they determine their own way and they route the data properly to the destination. There are two types of routers. One is the static routers and one is the dynamic routers. Now what is a static router? Static routers don't determine their own path. They are not much more intelligent. We have to inform them, or we can say we have to guide them in each and every network in order to transfer the data from one network to the another network. But dynamic routers, they are very smart. They have their own feeder algorithm inside. They properly route the data without any disturbance. Mostly we use dynamic. Static routers do not determine the paths. Dynamic routers have a capacity to determine their own path or route. So this is all about your routers. Let me show you few diagrams of routers. You can see here how the router has been routing the data from one to another, and that you can see that some numbers are written in the second diagram. They are nothing that the address assigned to them for transferring the data. This is a router, how it plays an important role in a wide area network. You can see here there are many webcam, computer, hard disk cable, printers, media, iPhone and digital camera, laptop connected together to form a bigger network than my LAN. Now let me discuss the function of router in detail. I'll give you an example. I'll give you an example how a router plays an important role in my telecommunication. For example, whenever the telecommunication plays a, as I said, it plays a very important role. For example, if I'm giving a call to a person, I'm a Airtel subscriber. If I'm giving a call to a person who is using a Reliance, he's a Reliance subscriber. So he is in Mumbai. So how the call is routed? So when I'm giving a call to the person, the number will be first identified that this number belongs to the Reliance customer. So when I'm giving a call, first my call will hit the Airtel cell site, which is my home network. From that, with the help of the router will be properly routing the data to the Reliance network, that is the tower, and then the call will hit the person. So when it is routing the call, it takes some time. That is why whenever we are calling some person, it takes some time in order to connect. Similarly, for example, if the person is in roaming, he is in Delhi. So when I am giving a call to the person, the first my call will hit the Airtel cell site. From there, the call, that is, it will be routing to the Reliance cell site. Now, when it is routing to the Reliance cell site, it will search for the person which is not in Mumbai, but the phone, that is his home network, is of Mumbai. So, with the help of the Reliance network, that is, which is in Mumbai, will be routing, that Reliance will be routing the call to the person who is there in Delhi. It will first hit the Delhi Reliance cell site and then it will route the call to the destination, that is to the person. If both are in roaming, then how the call will be routed? A simple example. First, when I am giving a call, it will first hit the cell site which is there in Delhi. And then from Airtel, the call will be transferred to the Mumbai Airtel because my phone belongs to, that is my number belongs to Airtel. It will be routed to the Airtel cell site in Mumbai. From Airtel cell site, it will be routed to the Reliance cell site which is in Mumbai. Then it will be again routed to the Delhi cell site which is there in Delhi, and then the call will reach the person. That is the reason that whenever we are going for roaming, the time taken in order to route the data will be little bit more. That is why we receive the call. Whenever we are calling the person, the time taken to route the call will be taken a little bit more time. That is how a router is going to work in my telecommunication. It plays a very, very important role. The other two connectivity devices are bridge and switch. We will discuss about it in short later on. By this, we complete the concept of connectivity device. So in connectivity device, we have discussed about modem, repeater, routers and hub and its types and its specification. Let us go to the next concept that is called as Ethernet. Now what is Ethernet? So firstly, network architecture. Whenever we work on network, we come across several network architectures. The architectures are designed in such a way, in a systematic way, to solve specific problems like that physical layout of connecting devices, cables, network cards, and protocols. There are two popular architectures widely used. One of the architecture is Ethernet, and one of the second architecture is the token passing. So firstly, today let us discuss about Ethernet. Now what is an Ethernet? Ethernet is nothing. It is an extension of LAN. When I discussed about LAN, I said LAN is going to connect 10 to 1000 computers together in a network. That is my LAN. But if I want to extend my LAN, but it should, I'm not going for MAC. If I want to extend my LAN, for example, if I want a LAN connection which is operating within a single building. So whenever a LAN which is operating within a single building, that is nothing which is called as Ethernet. A LAN which is operating within a single building is called as Ethernet. So firstly, before going ahead with the discussion of Ethernet, let me speak about the kilometers. The Ethernet connection we can use only for few hundred meters. But nowadays the modern Ethernet, because of my connectivity devices, because of my advanced cable, it can spare up to 10 kilometers. Normally we were using coaxial cable for connection, but nowadays we can use even twisted pair cable, and even the modern Ethernet uses fiber optics for communication. Now let us discuss first the diagram. So here I am having four computers A, B, C, D. All these computers and a file server. So all these computers are connected to the cable. So you can see how the connection has been done. It is similar like my bus topology. The structure, if you can see, if computer A want to transmit the data to computer D, for an example, what it will do, it will send the data inside the Ethernet cable along with its source address, that is of A, and the destination address, that is of D. So it is sending the source address of A and the destination address of D. So what will happen when it is sending the data inside the Ethernet cable? All the computers will be checking at the same time. That is B, D and C. All these three computers will be checking at the same time whether the address matches to it or not. So who will accept the data? D will accept the data and B and C will ignore the data. So D will accept the data and B and C will ignore the data. The similar process takes place if D want to transmit the data to C. So when it is transmitting the data via the Ethernet cable to C, B, C and A, all the three computers will check the data at the same time. B and A will ignore and C will accept the data. This is how a transmission takes place in Ethernet. As I said, the diagram is similar to my bus topology, but in bus topology, each and every time the node comes first, the data comes to the node, the computer matches whether the node matches or not. If it is not, then it will transfer the data to the another node. It is here, it is not like that. All the computers will be checking at the same time. Now Ethernet, the data will be not transmitted in the entire thing. The data will be broken down into small frames called as packets. Each packets will be having their destination and the source address. Now let's learn about Ethernet. Ethernet is a simple method connecting many computers together in a LAN. Ethernet is a local area network technology with network traditionally operating within a single building. Ethernet devices can have few hundred meters of cable between them. Modern technology allows Ethernet to span up to 10 kilometers. Ethernet devices are connected to a common shared medium, provides the path along which the electronic signals will travel. Historically, this medium was coaxial, but nowadays twisted pair cable or fiber optic cable are also used. So, in Ethernet, as I said, we can span only up to few hundred meters, but the modern Ethernet can span up to 10 kilometers. We are using a common shared media. Initially, it was only coaxial cable, but nowadays we are also using twisted pair cable and fiber optic cable. Now, how the Ethernet connection is achieved? It is nothing. If I want to achieve an Ethernet connection in the entire building, what will I do? A common backbone cable will be lying from the top of the building. From the top, I will make the connection. That is from the terrace to till the ground floor. A common cable will be running, and in each and every floor, the connection will be achieved with the help of the repeater, which is your connector. Ethernet network transmit data in small units called as frames. As we said, the entire data will be broken down into small units called as packets. That is nothing but the frames. Each frame must contain the source address as well as the destination address, which identifies the recipient and the sender of the message. The address will uniquely identify node. No two Ethernet devices can have the same address. When a collision takes place, it stops transmission of workstation and allows to retransmit after random interval of time. So as we have discussed, whenever there is a collision going to take place, the Ethernet will stop transferring the data, and after some time again the data will be transferred. That is, if one computer is transferring the data to the other computer, if A is transferring the data to the other computer, D, if B is already busy in transferring the data to C, so the network is busy. So what will happen? A will not transmit the data. It will stop for some time and then it will transmit. A system of connecting a number of computer systems to form a local area network with protocols to control the passing of information and to avoid simultaneous transmission by two or more systems is called as Ethernet. So it is a system of connecting many computers together in the LAN. Just simple words to remember. LAN, we know it is a local area network. It is a small area network. If I am going to use a LAN to operate within a single building, that becomes the Ethernet. That becomes the Ethernet. Now, whenever the data has been transmitted, as we said, it is transmitted in small packets called as frames. Each frame will be having the source and the destination address. Now, whenever the data has been transferred from one end to the another end, all the computers will be checking at the same time. If the address matches, which computer address matches, that will accept, the other computers will ignore. Okay, and a common backbone cable will be lying from the top of the building, and each and every floor will achieve the connection by using a single repeater, which is a connection. So you can see here, this is the diagram of Ethernet again, where the server, computers, all are connected to the Ethernet cable. So when computer want to transfer the data to the other computer, it is going to take place via the Ethernet cable. so that the data get transferred in a smooth way. So when that one computer is transferring, all the computers, all the devices attached will be checked. Whose address it is going to match, he will accept, the other computers will take. So in today's class, we have learned about the last connectivity device, that is router, and a new network architecture which is nothing but the Ethernet. In the next class, we will discuss about Ethernet and its types in detail.
Thank you.